Engineering theme park rides is a challenging business. You have to delve deep inside the human mind to grab riders physically and psychologically, manipulating fear and pleasure to deliver even bigger experiences.
Absolutely beautiful.
It's all part of creating the next generation of thrill rides.
Oh, God. Oh.
It's a cutthroat business with billions of dollars at stake. If you're going to succeed in the thrill ride industry, you need to push the envelope. You're going to have the very best technology and attempt the impossible to stay ahead of the game. It's a challenge that designers and engineers totally thrive on. This is Fahrenheit, a coaster taking human fear in a completely new direction. It's a terrifying ride with corkscrew rolls, a cobra, and an inverted S roll. But thrill seekers are coming to Hershey Park, Pennsylvania to try out a completely unique experience. They want to take a drop that messes up your mind.
We want each ride to have a signature, and it has to be unique to Hershey. And it ended up that we have a 97-degree drop for the ride.
What did he say?
That we have a 97-degree drop for the ride.
Sounds impossible, but when this track drops, it goes backwards, 7 degrees further than a straight vertical drop. It's total psychological terror. You feel like you're falling out of the train as your brain goes into complete fear overload. The drop is one thing, but it's the slow 90-degree climb, eyes looking straight into the sky, that creates a huge sense of anticipation. You feel your heartbeat in your throat.
So you have that psychological impact on your eyes, and your body saying, no, no, this is happening. So you're playing with all these pieces.
Kent Backman has been designing coasters for over 13 years.
This is like the greatest laboratory in the world for an engineer to play with: the physics, all the sciences, all the disciplines. And this is the closest I'm going to get to NASA.
After the drop from hell, Fahrenheit delivers all kinds of cool twists and turns.
Each component is unique. The large 107-degree loop, and this cobra element, and the twist and turn and high-speed banks. Throughout the elements of the ride, we're changing the energy levels, and we're manipulating gravity. And we're playing with gravity.
Designers were challenged to create a compact coaster with new innovations.
When we first decided to add a roller coaster in 2008, we had to first determine where we wanted to put it. And this space, as you can see, had a number of construction elements already around it.
Fahrenheit was built in just 4 months. It's 2,700 feet of pure tubular steel track. And it's this piece of the jigsaw that's most crucial to Fahrenheit's success. Perfecting a 97-degree drop was a tough task, but why not 98 or 100? It was down to the train's articulation. In coaster terms, that's the space between cars, allowing them to move freely without getting jammed.
We could take it up to 97 because the trains have articulation of about 38.4 degrees and about 10 and a quarter this direction. So you have a lot of movement between the front seat and the back seat. If we would have gone further, then we'd have to redesign all the trains.
There are only 3 trains, each carrying a maximum of 12 riders. Their length is also dictated by the compact design of the track.
People say, why is the train so short? The train is short because, remember, I said there's a lot of articulation, a lot of rotation between the track. This is more of a road handling course. There's very tight turns, very tight twisting, where we couldn't use a normal train to do that.
Trains were one of the design elements. They also needed this drop to be as dramatic as possible, and that came down to some simple physics.
When we set the top height, that gives us all the energy we need. And we're coming out of that first drop as a tremendous fall. We developed close to 4+ Gs coming off. So that train that's 6 tons, now times 4, is 24 tons of all energy, of total pure energy. And that's what rock and rolls and allows us to go around this whole track.
Physics is all fine and good on paper, but to test the world's first 97-degree drop, the job was left to a bunch of dummies. Dummies used to be filled with sand. Now engineers use water. The sloshing around of liquid is more representative of how the human body behaves. It also gives a better understanding of the G-forces, making you feel heavier and lighter during the ride.
So as you drop, coming off of this drop, the first drop, you're about 4 Gs. So if you're 100 pounds, you're going to experience somebody who's like 400 pounds. And then we come out of that G, and we take you right up to maybe a half a G. So now you're 50 pounds, and you're like floating on air. So we're playing with that. We're manipulating with all the G-forces.
4 Gs is roughly what astronauts experience on a space shuttle launch. It's important riders only experience this for a few milliseconds. Otherwise, they would black out. Safety checks are rigorous. When you're going this fast, any malfunctions would have devastating effects. When this ride kickstarts, it's non-stop for 12 hours. In just 1 week, the train travels over 1,500 miles. Proper maintenance can mean the difference between life and death. Within minutes of opening time, Fahrenheit is ready for action, and adrenaline junkies get in line. Among them is Brendan Walker, a self-confessed thrill seeker, but one with a purpose. His aim is to decode what happens to our bodies in thrilling situations and use the data to help designers take their creations to the very next level. Today, Brendan and technician Stefan are conducting an experiment at Hershey Park. Their subject, Fahrenheit. They will test how each drop, twist, and turn affects Brendan's body. The data will offer designers an insight into the different thrills this coaster delivers and ways they can tweak and improve rides in the future. Changes in Brendan's heart rate will highlight arousal, measured by an electrocardiogram.
This lead here is connected to my side here and one up here, so that's measuring activity across my heart.
Signs of pleasure and fear will be picked up using these electrode sensors on Brendan's face muscles, identifying smiles and frowns.
I'm just going to wipe some alcohol gel on here, which is going to take off all the dirt and grease and sweat which is built up there.
I don't like how you're saying that.
Sorry.
Sweat glands on Brendan's hands will open up during the ride, causing changes in electrical activity, another indicator of arousal.
They're actually putting electric current through Brendan's fingers, and just the changes in that electric current is what gives us a signal that tells us more about the kind of level of arousal that he's experiencing. And these struts here.
A specially designed helmet will also capture every facial expression.
It's good.
Brendan is suited, booted, and ready to ride.
Let's go. You ready, Steph?
Yeah. All ready to go.
Good. Excellent. We're looking down. Oh!
How will Brendan's body react to this?
Right down. And a twist as well.
And later, we go deep inside Niagara's fury, and riders get hot under the collar of the ferocious X2. Roller coasters are designed to stir all kinds of emotions with every twist and turn, delivering a different impact on the rider. But is it possible to measure physical reactions like fear and pleasure? Welcome to the world of Brendan Walker, one of the world's leading thrill ride experts. Brendan has come to Fahrenheit to show designers if the thrills they've promised really deliver. He's joined by thrill technician Stefan, who helped gather and decipher the data.
To be able to actually put a human guinea pig on, like me, and actually monitor the effect it's really having on a rider, it's going to give them a real insight into the effectiveness of what they've designed.
What happens to our body on a high-octane coaster? Brendan's about to find out.
So we're leaving the station now, looking around. I've got my first sight of the rise coming up against me. A sheer vertical climb, so we're trundling towards it now. It's a beautiful sunny day. So we're going up now.
He's wired up to record his heartbeat, face muscle expressions, and sweat gland response.
Going up into a vertical position, pointing directly up at the sun. Absolutely beautiful, clear day. I'm trying to look left and right. I can just about see the Hershey sign on the hill.
He's about to experience 85 seconds of extreme fear and pleasure.
We're topping out, we're topping out. God, the view's amazing. We're looking down. Oh, God. A little shimmy and a barrel roll around. Straight down, right around, and a twist as well. And straight out towards the ground. This is amazing. Oh, it's way too soon. Around, oh, the ground zooming up so fast. And around again. Oh, my God. Oh, no, it's another tight roll. And another. God, this is amazing. And another coming round. Over. Whoa! A little bunny hop there. We're stumbling back into point now. Oh, slowing down. So, slowed right down. So we're about to come back into the station. That was absolutely amazing. Just what you need first thing in the morning. It was extreme and intense.
Brendan and Stefan are eager to see the results. They want to find out if the data validates the experiences designers set out to deliver.
We've got 7 data streams coming in. So all of these things have helped us pick out these various ride features.
Each one of these graphs shows a different level of reaction in Brendan's body. They first take a look at his arousal, which they expect to increase dramatically.
Actually starting to climb. In fact, now we are climbing now. We can see here from that accelerometer. So I'm getting spikes in pleasure as well. So I'm finding something quite entertaining.
In anticipation, the heart rate reaches its peak before the action really begins.
And you've now hit a really big plateau in heart rate. It's 140, 150, which is around all the way.
Brendan's has gone up from 60 to 150 beats per minute.
On the hill, we're topping out, we're topping out.
His excitement is really building, and the ride is clearly working.
God, the view's amazing. We're looking down. Ah!
So one expression, which is quite interesting there, is this big kind of open-mouthed kind of shout, scream.
Yeah. So it's almost like a scream, but of pleasure, as opposed to a scream of horror.
Yes.
Yeah.
After the drop, the heart rate levels down to a more manageable 120 for the rest of the twists and turns.
So into all these amazing twists and turns and getting little spikes again. Yeah, still getting good spikes in pleasure. And you can see definitely on my face here, I'm really having a good time.
Yeah.
Next, they take a look at the facial expressions. The frown muscles are indicators of fear, while the smile muscles register pleasure.
Actually, by looking at the sensors and looking at those very particular muscle groups associated with those emotions, whether it's pleasure or fear, we can actually discern those difficult-to-read facial expressions. We can actually discern whether they are through pleasure or fear. The fear now has completely plateaued out to the bottom, almost getting, flatlining. And the heart rate's still very high.
Yeah.
Brendan starts to really enjoy himself. The heart rate has plateaued, and his sweat glands have opened up, revealing spikes of pleasure as he goes through the rolls.
This whole section is completely maxing out on both.
Now we're coming into a very tight curve, a 360 curve.
Yeah, so more pleasure here than fear.
Okay, 360 curve. Yeah,
a lot more pleasure here.
The ride is over, but Brendan's heart is still racing.
That's kind of interesting, coming back into the station. So that was, my heart rate's actually gone back up to 100, so there's obviously something quite arousing about seeing spectators, people I know. So there's definitely something about sort of the performance aspect of being on a ride. Get me out, please.
And now the rider stops, and your heart rate's dropped back to 90. So
and also, you can see as I started talking to people, the levels of pleasure started shooting up as well. So that's kind of nice, a bit of social interaction as well.
Yeah.
It's good.
Brendan and Stefan can now attempt to draw some conclusions. Right from the start, the ride is clearly creating a rich mix of emotions.
I think something we didn't expect, that after the moment of sort of fear and anxiety and that sort of period of mixed emotions as the ride's setting off. And we're feeling arousal, but also within arousal, you could also be feeling fear or pleasure at the same time. We're topping out, we're topping out. God, the view's amazing. We're looking down. That peak, I think it's a vertical drop, but in fact it's 97 degrees. And at that moment, I remember being shocked by, what I was experiencing. I didn't expect that at all. I think my fear level shoots up, but also I experienced a huge spike in pleasure as well.
The analysis proves designers succeeded in creating sensations of pleasure after the initial terrifying drop.
You can see a drop, so looking at my GSR and heart rate, I'm sort of getting into a zone of serenity. So actually, it's a period where I'm kind of reassessing, sort of rebooting, and sort of in psychology terms, that's sort of reaching a kind of baseline, normalising myself again. So it's kind of like preparing me for the onslaught of effects.
This ride mixes fear and pleasure to create a great sense of thrill.
Yeah, I think we can safely say that the ride design has been hugely successful in creating a very experiential ride. Yeah.
One surprising piece of data makes Brendan think engineers have missed a trick. The train comes to a dramatic break at the end of the ride. A spike in Brendan's heart rate indicates fear. Brendan thinks designers can offer riders a quick payoff of pleasure, and a music effect could do the job.
So there could be an event that should immediately follow that breaking moment. If I were revisiting this ride as a ride designer, I would be looking for opportunities at that point to inject some level of pleasure. It could be something as absurd as introducing some silly pop song or something that just makes people smile, but just a split second after that break.
Absolutely awesome. Fantastic.
Coming up, the next generation of virtual reality on the edge of Niagara Falls. And a coaster so fearsome that to ride it is to conquer it.
Do not resist.
This is Niagara Falls, one of the natural wonders of the world, but also one of the most perilous places known to man. Many lives have been lost tackling these ferocious waters. 37 million gallons of water roar over this edge every minute with the power to decimate a 2-ton truck like an accordion. It's a sight that conjures up all kinds of emotions in its visitors. Thrill, vertigo, danger. Imagine if you could soar above the rapids, dive deep into the mist, feel the rush. It's an experience thrill ride designers have accomplished. This is the next generation of high-tech thrill rides. Niagara's Fury is a brand new take on virtual reality. The goal was to create an experience of how the falls came to be, from the Ice Age to the modern day. The challenge, to build the world's first 360-degree seamless cinematic experience. To give it even more impact, they added Hollywood's latest special effects and built a high-tech motion simulator.
One of the things that we asked the engineers to do is not make this just a ride where you put on some funny glasses and things come flying at you. We wanted really real things flying at you. So we have water coming at you. We have fog, lightning, high-tech sound.
And it's this technology that creates the illusion.
A lot of theme parks is essentially magic tricks.
Designers and engineers worked around the clock, developing and testing technology to create a one-of-a-kind ride. No one has ever experienced the falls like this before. It's 2 days before the scheduled opening, and there's still a lot of work to be done. The attraction is already delayed by a week. Nerves are frayed. The pressure is on John Erickson, the technical director. The effects are malfunctioning. Each hour of delay cost Niagara Parks owners thousands of dollars, and they're already over budget.
The fans aren't working.
John has been here before. He has worked on some of the biggest movie rides, from the much-loved Terminator 2 3D to Men in Black, pushing technology to the max.
They call it the bleeding edge instead of the leading edge for a reason. You know, anytime you get new technology, you always run into problems that you weren't expecting. And that's the biggest part of this task, is working through those problems.
There are problems with the timings of the show. John needs more wind and fog. He's going to spend the day fine-tuning for maximum effect. Small last-minute hurdles in comparison to what they've overcome to get this far. Rides of this caliber cost up to $100 million. Niagara's Fury is the exception. It was built for a mere $7 million. It's been 4 years in development and 18 months in construction.
We spent 2 years traveling the world, looking at different applications, different products, from going on to a ride where they're using heat and saying, well, why can't we do that, only make it cold? And you get the thought process going, and that's the start of the creativity.
The trick is to write a heart-pounding story with special effects to match.
The biggest difference between this and movies is movies, you got to make it work maybe 3 times and then you're done with it. This is supposed to run 12 hours a day, 7 days a week for 10 years.
Yaz and the team came up with a solution. They've used digital cameras to manipulate the final product in the edit. They captured the majority of footage using a 9-camera rig suspended from the bottom of a helicopter. These visuals transport the audience on an incredible journey into the falls. Visuals are one thing, but how do you give the rider a fully charged Niagara experience? Engineers came up with special effects to reach out and touch the audience. Blowers create conditions for the ice age. Different snowmaking recipes were tested. Bizarrely, soap did the best job. It creates small bubbles that look like snow, fall like snow, and evaporate before hitting the ground. Temperatures can also drop 35 degrees in just 3 seconds. It's the first time thrill ride designers have been able to control heat and cold in this way.
It is cool.
The audience is freezing, but what they don't know is that a massive thunderstorm is right around the corner. A highly powered sound system intensifies the atmosphere. This is the most realistic fake thunder you'll ever experience. Speakers produce low-frequency vibrations below 20 hertz, sounds you can actually feel, the same sensation the body gets from the bass of a loudspeaker.
These are rotary subwoofers, and the way this works is these are industrial motors that spin at a constant RPM. For the most part, you don't really hear it, but you feel it.
The engineering team didn't stop there. They wanted to create a physical experience that terrified riders. A motion simulator creates a thunderous vibration through the body.
Underneath this platform, we've also got a pneumatic shaker. When we do the lightning strike, and when that ground starts to charge, you just feel a whole vibration going through your body, and that's the idea. We just go bzzz, bam! Pretty effective.
This production has had its share of problems. 2 days before opening, the team is ready to wrap. But director Yaz wants to make Niagara's Fury even more thrilling. He needs extra close-up visuals to give the audience an enhanced experience. Flying over the falls is a highly dangerous operation, but this team are willing to go the extra mile. Going this close to the edge is a matter of life and death. Extremely careful piloting is required in Niagara's unforgiving microclimate. Coming up, the death-defying helicopter shoot. And a coaster designed for the toughest of riders. This Hellraiser really gets its riders fired up. Niagara Parks is creating a one-of-a-kind, breathtaking experience for their visitors. They have their work cut out. After all, they're competing with Niagara Falls, one of the world's most awesome natural wonders. The tech team have been working day and night to complete the ride. Yaz Takata, the visual director, and a group of Tinseltown's best special effects wizards are preparing for one last shoot. They need to capture extreme close-up shots from a helicopter, just 50 feet above the fall's edge, but it's a very dangerous shoot. Niagara has a sensitive microclimate. Its mist causes ever-changing temperature and wind conditions, and this has caused fatal helicopter accidents in the past. They'll be using 9 high-resolution cameras and a specially designed rig. These powerful digital cameras were developed for satellite use. This is the first time they've been used in a 360-degree shoot. Yaz needs to capture new close-up images to give the audience a one-of-a-kind experience of what it would be like to actually fly over the falls. The images will be projected on a screen with no dividers.
What's unique about this 360 as opposed to 360s from the past, it's seamless. There's no emollient. So it's a complete 360, edge blended, 9 separate screens, 9 digital cameras.
The weather is acting up. Too much wind means they'll have to call off the shoot. They finally get clearance from Canadian Air Control to fly before the clouds roll in. Few pilots are ever granted permission to get this close to the falls. A few years back, 2 helicopters collided with several fatalities. The team have to guide the rig, making the takeoff and landing extremely dangerous. One false move could flip this chopper.
126.5, thank you.
This customized rig took more than 6 months to build, costing $500,000. The cameras record 2 times the resolution of ordinary high-definition video. Their high-spec wide-angle lenses create amazing 360-degree panoramas.
It's beautiful today. That's it, nice and smooth. We are speeding.
The wind is starting to pick up. A wild gust could put this team's lives at serious risk. It's a treacherous flight over the Niagara River, but they need to get shots of this white water. These rapids are rated Class 6. That is the highest rating. Boating of any kind is strictly prohibited.
It's gentle enough. Beautiful.
They finally arrive over the falls, and what a sight it is. They fly over the horseshoe in a circular formation to make sure they get all the best angles. These are just the pictures the team set out to get. The weather conditions are perfect.
That was pretty neat.
During the flight, the chopper gathered 20 kilovolts of static electricity generated by the blade's friction with the air. If this isn't handled properly, it could cause the fuel to explode. A static stick is used to discharge the electrical output. Everyone lands safely. Another shoot is not an option. They have less than 2 days to get the experience of the falls perfect. Yaz makes the final call. He needs these images to create a realistic sense of what it's like to go over the falls. But will these shots have the wow factor he's looking for?
Okay, we're done.
The shots are approved. The director of photography is relieved.
See how close they were to the edge? Oh, man.
The next step is merging the visuals into the 360-degree video.
I have to take all those footage and stitch them together, which is basically a 360-degree strip, which is 9 high-def video cameras.
Back in the theater, John is concerned that the water bursts aren't firing properly. Guests have traveled from all over the world to be the first on the ride, and nobody wants to let them down.
For the first pass, we'll get the wind down.
Yeah, wind for sure.
Wind and volume.
They've been working around the clock to make sure all the elements come together. The big day is here. It's the moment of truth for Niagara's team. It's just seconds away from what they hope is a mind-blowing experience. The audience is hooked. Time to soak up the falls in all its glory.
One of the most exciting things about the process is actually seeing the smile and shock on its faces. Having taken it from pencil sketching to a final product today, it has been probably 4 years of my life.
Coming up, a ride that takes fear levels to a new dimension. But how have designers given X2 a really X-rated boost? Somewhere in the desert, where only brave souls tread, a magnificent beast perches itself on a hill. It's a machine so ferocious, so fast, it makes the human heart beat like a jackhammer. If you enjoy being scared out of your senses, then X2 is the ride for you. At Six Flags Magic Mountain, riders plummet 200 feet to the ground, face down, and hurtle at speeds over 70 miles per hour through this massive twisted steel maze.
It is an intimidating ride. You really have to decide if this is something you want to do. It is an intense, intense ride.
The designers of X came up with a unique coaster structure, rotating riders 360 degrees in seats suspended from the train's sides. Only 2 coasters like this exist in the world. X was the first, and the second is in Japan. In 2008, X was revamped. Designers reduced the train's weight by 20%, improving reliability. They also took the opportunity to totally revamp its personality. It wasn't just a paint job. State-of-the-art video, a high-tech onboard sound system, and some incredible special effects were also added. The result? A terrifying experience.
Oh, if X2 had a personality, he'd be your big superhero. Not a positive superhero necessarily like Superman, but the darker superhero like Terminator.
Tim Burkhardt is the general manager of Six Flags Magic Mountain in California. He designed the original X and helped transform it into X2.
Well, what was really neat about the rotating seat design on this coaster was it really allowed us to play with the forces that a rider would experience on a ride and rotate the seat as the train moved so that we could put the forces not only in a safe manner so that it's pushing people down and back into the seats or being uncomfortable, banging your head or things like that, but it also allows us to get a new enhanced feel.
The X was known as a 4D ride because it moved in 4 dimensions. Spinning on a coaster was totally novel, especially at these G-force levels. It packs a stupendous 4.9 Gs. That's what a Formula One driver endures cornering at high speeds. But designers and engineers wanted to deliver an even bigger, scare the hell out of you X-rated thrill. An $11 million upgrade took this coaster to a new level of intimidation. The revamp is full throttle. The central element of its redesign plays on the psychology of fear.
One of our goals with reintroducing X as X2 was we needed something else to complete the story. We did the new trains, we did a new paint job on it, but how do we finish the story and really give people a chance to come out and try it again?
The makeover incorporates terrifying special effects, like flamethrowers designed by a top Hollywood pyrotechnic team. A misfire could seriously burn riders, but a sophisticated computer system measures the wind and fine-tunes the flames.
You have no idea when this flame is going to hit you, and it's all of a sudden, boom, there it is.
These special effects have transformed X2 into the world's first roller coaster with 5 dimensions. Stephen Keeney is Vice President of Development at Six Flags. He assembled an all-star cast of designers to retool this coaster into a dark and terrifying new experience.
This ride has a voice, this ride has a personality, and when it comes to the onboard audio and the effects, the level of choreography, I think, is beyond anything we've done before.
The challenge is to heighten the psychology of fear, boosting a heart-thumping response with riders. They use a series of subliminal voices.
Behold the thunder of X2.
And state-of-the-art graphics. A music system was also added, delivering a highly charged soundtrack narrating the experience.
At the beginning of the ride, there's security checks that have to happen. So to address that waiting point, the whispering voice saying X2, X2, X2.
Are you ready to take thrill to the next dimension?
That's where we're starting to build a little tension. I'm going to let you in on a little secret. We hit everyone with some great, really rocking music. And we mixed in sound effects of people cheering and whistling and hollering. And that was done, you know, on purpose, you know, to try to generate that feeling of conquering when you get off the ride.
As riders wait for takeoff, there's a growing sense of anticipation and fear. They know it's too late to change their minds. A graphically explosive video plays dramatic images over in their minds, heightening the suspense.
We went into the video game world. This is meant to serve as, we're just feeding your head. We're getting your mind to start working in a certain direction.
Do not resist.
Next, step right inside a high-tech video game to find out how Disney has created an incredible futuristic ride. These days, the holy grail for designers is to deliver a truly interactive experience where riders become part of the story as well as the action. Ride films are the latest rage. At Universal Studios, the new Simpsons ride has a cutting-edge simulator and video system that links up to 140 monitors and two 80-foot IMAX screens. They've engineered the drops, twists, and turns of a real coaster with Homer and his family interacting right alongside. At Six Flags, the latest Batman ride, Dark Knight, uses high-tech video, sound, and special effects to bring guests a one-of-a-kind dark ride experience. Riders are even turned into citizens of Gotham City as they venture through demented hallways of twists and turns. But when you want to glimpse the future, you go to Disney. They're the proven masters in thrill ride development. With Toy Story Mania, Disney has achieved a totally unique virtual environment. Call it a ride for the Wii generation. It's like a computer game on wheels.
They have no idea the amount of technology that is behind the scenes.
So if you have ever wanted to be inside the screen, here is your chance. Riders enter the world of Buzz Lightyear, Woody, Bo, and Toy Story's other iconic characters, gaining points by shooting at 3D moving objects. The ride is a carnival experience, interacting in a fantasy world of toys to get the best score. You'll throw pies, fire darts, and chuck rings while objects come flying towards you. Just like in a video game, each ride is unique and different. Computer processing power on this ride is so big, it can directly interact with every person. For Sue Bryant, Toy Story Mania's show producer, the storytelling was paramount.
The idea was to try and let the guests actually enter into the world of the Toy Story movies, but as an honorary toy. So we want them to feel like they're at toy scale and they're in this world with all of these great big toys and, you know, objects that are in Andy's room. You want it to feel real. So all the materials, the plastic and the cardboard, behave the way they would if you were actually shooting little baseballs or little darts into the games.
This is the world's first 3D interactive ride, where the line between animation and reality blurs. But Disney didn't stop at 3D. To really immerse the rider, they brought in some 4D effects. 4D means riders might feel wind, heat, and water, making the ride come to life even further.
You shoot at something, it does something, it comes towards you, the 3D glasses, the audio comes towards you, and then poof, you're hit by something.
One of the challenges was creating the technology behind the spring action shooters used on the cars. Sue discovered that kinetic movement, like pulling on a string, was a lot more engaging than pressing on a button.
We looked at a lot of different trigger options. We looked at levers, we looked at buttons, we looked at all sorts of crazy ideas and really landed on this string. You're pulling the string, you're moving the shooter around, is, a pretty simple thing to do. Completely intuitive and physical. It's something that really pulls you into that world.
Each projectile behaves as it does in real life, with hundreds of sensors behind the scenes making this possible.
We wanted each of the objects that you shot out of your spring-action shooter to be very believable as far as the world of physics and logic. And you'll see all of the targets come up in a mechanical fashion. If you throw a ring out in the ring toss game, the ring is going to land on a flat surface if you miss and go wow, 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 and just stay there.
So how does Buzz know when you are shooting at one of his toy soldiers? 90 onboard computers communicate 60 messages every second. Through a series of motion sensors and a specially designed programming language, messages tell the animation where your projectiles are and assign cartoon characters real-world behaviors.
Toy Story Mania always knows where you are and what you're doing, and the world is always reacting to everything that you're doing. Lighting and audio, music, the characters, they all know exactly where you are, and they're all playing off your location. All of these technologies are communicating with each other in real time to make that all seem really seamless.
The more you ride, the more you discover the layers of secret hidden stories.
There are easy targets, there are harder targets, but we also have what we call two-stage targets, where you hit one target and it triggers another target.
Engineering high-tech software-based rides has one distinct advantage. They have the capability of being supersized at short notice.
If we want to develop a new game offline, we can do our testing offline and then bring it in and install it and, almost overnight, really have a brand new game for people to play.
The thrill business is facing a rapidly changing world. Riders want to step up from the video game experience they're used to. Designers have to be on the cutting edge of technology to take the crowds to a new level and keep them coming back for more.